till here the P1 has sent their offer and P2 has accepted the offer and then created an answer, which again P2 sends over to P1, right? And P1 accepts that answer. So till that they have exchanged their capability and they have agreed upon, like, okay, now we can connect, right? So now the connection part comes into the picture where both the peer will now try to connect. Okay, so how that happens, let's see that, right? So suppose there is this network. Okay, this is a private network. Okay, most of the time every machine, right, which is connected to the internet, like your laptop, right, or your computer, personal computer, they will be sitting inside a private network, right? It will be connected to Wi-Fi or some router. Okay, and your machine, suppose this is the P1, your machine will have a private IP address, right? Something like that. If you check 162 192.168.1.30, something like this. Okay, you will have this private IP address assigned to this. Okay, so using this private IP address, no one can reach out to you, right, from the outside of your network, right? So usually what happens, there will be a router sitting here, okay, which connects you to a public internet, right? Similarly for the P2, it stays in a private network and it will again have a router which will connect this peer to the internet, right? That's how you communicate. Why you are able to communicate like this? Because this router will have a NAT mapping, something called NAT mapping, right? It is called network address translation, which means this router will have a public IP address, all right, and you will have, this peer will have a private IP address, and there will be a mapping created here. Okay, so there will be a mapping like private IP plus port, and it will be mapped to public IP plus port, okay, of this router, public IP of this router. Okay, that way, suppose you are sending a packet, from P1 to outside. Okay, so whatever packet, whatever response you get from outside will come to this router using this public IP address. Okay, and here it will see this mapping. Okay, so which private IP and port I have to forward this packet to. Okay, so based on this mapping, it will be sent back to the peer, right, this machine. So in case of WebRTC, we don't have client server architecture, right? So what happens, you have to figure out your public IP address, so that since you want to connect directly, right, like this, so both the peers, what will they do? They will have to exchange their public IP address. By public IP address, I mean this address, right? Because whenever someone sends any packet to this address, this public IP address, and this port, it will be forwarded back to this private, right? But this private is not relevant for outside of this network. This won't be relevant because this same IP and port can be, this 192.168.1.30, that can be assigned here also and here also. So this can be repetitive. This is just private. This is just a private IP address. This is only, until unless you enter this private network, you won't be able to locate this machine using this address, right? So the same address can be here also, because this also can create a private network where you have address like this. But in order to uniquely identify this machine or this machine, it needs a public IP address, right? So this public address and this private IP address, this is what going to uniquely identify this machine over the internet. Okay, that's how this machine will be able to receive any packets, right? So till here, I hope you understand what is NAT. Okay, and why do we need it? Okay, because of IPv4. Okay, because of IPv4. If you don't know what is private IP address and what is public IP address, again, just look why this was created, and just search on Google, and you will get to know. Because of this IPv4, we have very limited number of IP addresses, okay, compared to the amount of machines available on the internet or connected over the internet. Because of that, this concept of NAT comes into the picture, where you can, with a single public IP address, you can connect multiple machines over the internet, right? So that's how it happens. So now, using this mapping, okay, if P1 wants to connect to P2 and P2 wants to connect to P1, they will need to get this public IP address and send this public IP address to other side. Okay, P1 will have to send this public IP address to P2, and P2 will have to find their own. Okay, they will also have NAT table right here, and P2 will have some mapping, P2 let me call it P2 mapping here. Okay, so this P2 will have to get somehow and then send it across here, send to P1, and that way both the peer will know their public IP address and they can connect, right? Now, in order to get this public IP address, okay, you can't make request to router and ask, okay, give me this public IP address, right? Because router is not a server. Its job is just to forward packets across, okay? And there will be some, nowadays router has more capabilities like firewall configurations also, right? It works like gateway also. So I'm not getting into those things. For WebRTC, the important part is this NAT mapping, okay? And router can't serve you as a server. So you can't make request to router and ask for public IP address or public this mapping from the router directly. So for that case, we have another server, okay, and that is called as stun server. We have something called stun server, okay. Full form is stun is session traversal utility for NAT, okay. It's called. Right, so session traversal utility for NAT. So this is like a utility server which allows you to traverse through the NAT, okay. So what you do, you need this mapping, right? For that, all you have to do, make a request, okay, to this stun server, and this stun server will give you this mapping. How it does it? It's simple, right? Whenever a request comes to this stun server, it will know from where it is coming. It won't know the private IP address because private IP address is not routable, okay. So when the request goes from this router, it will replace the private IP address with this public IP address. So it will know this stun will get the information of this public IP address, and in the response, what it will do, it will simply put this public IP address in the response body, okay. In the response body, it will put this public IP address. It's not directly put, it's XORed, okay, but I mean that's not important as of now. Somehow just understand this public IP address is put in the body of this response and sent back to P1, okay. So here it is getting stun binding request and it is sending stun binding response. That's what it's called, okay. This is another protocol. It's not normal REST API call, okay. It's stun binding request and stun binding response. So in the stun binding response, you will get this public IP address, okay. That's how P1 will get its own IP address, and similarly P2 will again can make a request to this stun or any other stun. It doesn't matter. Somehow you have to make a request to any stun server and get your mapping, okay, public IP address, and finally you will exchange your public IP addresses, right? And that's how you can connect, right? Now, before we proceed further, let's understand NAT, okay. So there are three types of NAT mapping, okay. So first one is endpoint independent mapping, okay. The second one is address dependent mapping, and the third one is address plus port dependent mapping. So see, these are general terms, okay. These are general terms. There are different terms for different types of mapping, but they are generally categorized in these three categories, okay. So you might see like full cone, half cone, those sort of things, but they all fit into these three categories. I'm not going into those categories because that won't be very relevant for us to understand the WebRTC part, okay. So all we need to understand is these three categories, three major categories of NAT, okay. So now, in case of endpoint independent mapping, what happens? Suppose you have this P1, okay, and you have this NAT here, okay, and you have this, somehow this is this internet, and P2 is here, and this is its network, and this router, okay, and this is connected like this. So in case of endpoint independent mapping, what happens? Whenever any request goes out of this router, okay, outside this router, NAT mapping will be created, okay, just the way we have seen here, right? Address IP, IP plus port of private and IP plus port of public, okay. Just like that, the mapping will be created, okay. It doesn't matter where you are sending the request and from where you are getting the response, okay. In every case, just this mapping will be used, okay. It will be fixed. Doesn't matter if you have another machine here, P3, and you are sending request to this P3, okay, or some other network. So this mapping will be fixed, okay, in case of endpoint independent mapping. But in case of address dependent mapping, what happens? Suppose you have this P2 here and you have this P3 here. So if you send this packet from P1 to all the way to P2, a mapping will be created for P2, okay. Let's call it P2 mapping, okay. one mapping will be created for P2. And similarly, if you send packet to P3, okay, like this, so another mapping will be created in this case, P3 mapping. Okay, so in case of endpoint independent mapping, what was happening, there was one mapping. Okay, it was not created for every address you are trying to reach. Okay, so for every address there was just one mapping created. Okay, but in case of address dependent mapping, for every new address, by address I mean IP. Okay, for every IP address you are trying to reach from this endpoint, okay, a separate mapping will be created for it. Okay, that's address dependent mapping. In case of address plus port dependent mapping, can you guess what happens? If you have guessed it like this, what I'm going to explain, then you're right. I mean, it's very intuitive, right? So what happens? Similarly, in case of address dependent mapping, this mapping is created for every address. But in case of address plus port, for P2, if you have this process P1 and another process and another process, on one machine multiple processes can run, right? And every process can be a different service, right? HTTP, SSH, something like that, right? So for every processes, here it is going to create mapping. For example, let's assume this is gone. Let me remove it. All right, suppose P1 is trying to connect to this process. Okay, this process, let me call it small p1, small p2, small p3. Okay, so for every processes, one mapping will be created here for p1 and for p2 and for p3 here. So for just one machine you have three mappings created, right? Suppose you have sent one request to this P2, okay, all the way from this router network to this P2, and you have sent the request. Now you're waiting for the response, right, from the P2, and that time this P2 somehow gets deleted. Imagine like that. Okay, so when this P2 will send the response from this P2 process, small P2 process, and it reaches this router, it will check this NAT table, right, and it won't find the mapping for this process. If it doesn't find this mapping for this small P2 process, it is going to drop the packet here itself. It's not going to forward it back. This is like this. So endpoint independent mapping is lenient one. Okay, very lenient. Address dependent mapping is stricter than this one, and this address plus port is even stricter than that. Okay, so mapping is created like this. So overall we have these three categories of NAT. Okay, so just like this third part where we saw that if this mapping is gone for this process, if that process sends back the response, it will be dropped here if this doesn't exist. Similarly, for address dependent mapping, if you have different addresses, okay, if you have different addresses, for like here you have capital P3 address, so for P2 you have this mapping, and for P3 you have this mapping, and if P3 is trying to send back the response and this mapping doesn't exist, the packet will be dropped here on this router itself. Okay, it won't be forwarded back to P1. All right, so now I hope you understand all these three types of NAT mapping. All right, so now let's come back to this stun part. Okay, so using the stun, what we used to get the public mapping, right? Using this stun you get the public IP address of your machine, right? Now you tell me that in which case, like we have three different types of mapping, NAT mapping, right? For what mapping you can use the stun, and for what mappings you can't use them. Okay, take a pause, think about it, and resume the video. All right, so now the answer is you can only use stun for endpoint independent mapping. You can't use stun for address dependent mapping and address plus port dependent mapping. Okay, why? Because whatever public address you're receiving from the stun, you have to send that public IP address, that mapping, to the P2, right? From P1 to P2 you have to send that. What happens in case of address dependent mapping? Let's take this case. What happens in the address dependent mapping? You have sent this request, right? From P1 you have sent the request to the stun. So what will happen? This mapping will be created, okay, for this stun in case of address dependent mapping, right? So the mapping will be stun mapping, and when the mapping is created for stun mapping, only stun can send back the response, right, through this mapping. No other server or no other machine over the internet can send back the packet through this mapping, right, back to this peer, right? We understood here, right? Suppose you have mapping for P2 and you have mapping for P3, right? Here for P2 you have mapping, for P3 you have mapping here created. Now suppose, and I said like for P3 if the mapping is deleted, P3 can't send back, right? Suppose in case of stun, what happens? This, suppose this P3 is stun here in this case, okay? Suppose this P3 is stun, okay? You have sent the request here, okay? And this, and the mapping get created for the P3, right? But now this mapping, if you send to P2, this P3, if you send mapping to P2 and P2 is trying to send back you the response, you can't send through this P3, right? Because this mapping was specifically created for this P3, right? So for stun case, it will fail, okay, because the mapping was created, this mapping is created specifically for the stun. But in case of address independent mapping, what happens? This mapping was not created specifically for this stun, right? This will be a generic mapping. Anyone sends the packet from the internet to this mapping and it will be forwarded back, okay? Using this NAT table, it will be forwarded back to this P1, okay? So now you can see that if you can't use stun for address dependent mapping, you know that you can't use for address plus port dependent mapping, right? So for that case, imagine there is a server. Imagine that, suppose the host that is running this stun, what if the same host, let me clean it up a bit. Now let's imagine that the host, let me change the color here. Some machine will be running this stun server, right? Now let's imagine that this stun server, okay, this is the stun server, and now this stun server is hosted on some machine, right? There is a server on which this stun server is running, right? Stun server is nothing but a software, right, which is running on a server, okay? So imagine that this server which is hosting this stun, what if that same server relays the packet also? What I mean by that, suppose this P1 is connected to this stun server, right? And you got this mapping created, okay? Suppose you have got this stun mapping created here, okay? So in case of address dependent and address plus port dependent mapping, using this mapping, you can't, communicate with other peer or any other machine, right? Only this stun server will be able to send back the packet, right? So now imagine the server which is running the stun does one more job for you, okay? It creates this connection as well as it receives the packet from this peer and forwards it somewhere. For example, in this case, the P2, okay? It will send that packet to P2 and whatever response it gets from the P2, okay, it sends back that response using this mapping to this P1, okay? So if this server is able to do this, then our problem will be solved, right? Then we'll be able to make it work for all these three cases, right? For endpoint independent mapping and address dependent mapping and address plus port dependent mapping. Then for all these cases, okay, it will work, okay? Because beforehand, you don't know that the other peer, what if you are sitting in an endpoint independent mapping NAT, but this peer is sitting in one of these mapping, right? So you never know. So for that case, you have to make sure this connection works and you're able to connect, right? For that purpose, you can use this server which does both the thing for you. It creates the connection between that server and the peer, right? And also forwards packets for you, like relays the packets for you, right? So now the same server that we are talking about which solves this problem is nothing but the turn server, okay? This turn is nothing but, it's called traversal using relays around NAT. So it allows you to traverse, okay? And it allows you to, relay your packets around this NAT, okay? With this NAT, doesn't matter what type of mapping it is, this server will allow you to, relay those packets through this server, okay? That's nothing but the turn, okay? So there are so many, jargons in the WebRTC and it gets confusing. So now I hope this is clear. Why do we need stun and why do we need turn server, okay? Because stun doesn't fit all the time. If we can the stun, it's very good because it will be cost effective, because in that case you can directly connect these peers, right? You can directly connect these peers, you won't need any server, and you can directly exchange the packets, right? If you can use this stun server. But if you can't, then you'll have to, send the packets through this route, okay, like this. So in that case there will be a cost associated with the server, right? All right, so now you understand what is stun, what is turn, why do we need it. So till here we understand that signaling phase is over. This was the signaling phase, okay? And now we are now just entering the connecting phase, okay? Now here we have to establish a connection, and in order to establish a connection, there is a framework called ICE framework, okay, that gets used along with, in conjunction with, this stun and turn server, okay? Now how that happens, and how do we use it, let's understand that in a separate video, because I think it's getting a bit longer, right? See you in the next tutorial.